All right, hey, so when you get a rational function where this bottom piece is actually quadratic, so the big difference between what we're doing today and what we did in the previous lesson was maybe on the bottom part, we only had like x minus 3. And then, we would just sketch an asymptote at x equals 3 because we can't divide by 0. So anytime you're working with rational functions, I think a good first step, I'll just write it down here. Maybe a good first step to always approach these problems is to Boolean factor the function. That's the best first step that you can do. So hey, we've got this function up here, and we should realize that this quadratic piece on the bottom, the denominator of the fraction, x squared plus x minus 12, you can actually factor that and then find these asymptotes. I think it's the best approach possible. So again, what we're going to do is just factor anything that can be factored. Like, hey, this thing up here, the 1, can't do anything with that. The 2, it's just a constant value, can't factor it. But this quadratic expression down here, we can factor. Okay, so I'll just rewrite it. X squared plus x minus 12. And it's really why for Algebra 2, we've made such a big deal about factoring. It really helps with so many different functions. So to factor this, I think the easiest strategy is just make that x bar chart thing. Again, hoping you guys are pretty comfortable with doing this. So we'll put negative 12 up top and then positive 1 on the bottom. So we're looking for two things. What can we multiply to make negative 12? But add up to positive 1. Multiply that makes negative 12, adds up to positive 1. That would be 4 minus 3. Kind of checks all those boxes, right? 4 minus 3 is going to give you 1. 4 times negative 3 gives us negative 12. So this quadratic actually factors out to x plus 4 times x minus 3. Okay, so now that we've factored that bottom piece, this quadratic here, I'm just going to rewrite the function to make it more clear where I'm finding these things. We factored it, so now we can rewrite our function. F of x equals 1 divided by x plus 4 times x minus 3, and then still we have this plus 2 on the end. Okay, fantastic. Okay, so when you see a function like this, and it's already fully factored, we're actually ready to start doing some things to it. Yeah, we'll change the signs essentially in a little bit. So this function, this is not going to change. This number on the end, the plus 2, that is where you get the horizontal asymptote. This denominator piece, the x plus 4, the x minus 3, denominator is where you're going to find the vertical asymptotes. All right, so going back up here, these things that I wanted us to find. Vertical asymptotes, these lines that our function is going to approach but never actually reach. Remember, the key here is I can't divide by 0. So I'll kind of try to illustrate what I'm saying here on a calculator. This function, if I tried to plug in negative 4 for x, just see what happens here. So what I did was just replace the x values with negative 4. I'll hit enter and got an error. We can't divide by 0. The same thing would happen if I tried to plug in positive 3, because 3 minus 3 is 0, 0 times anything is 0, and I can't do 1 divided by 0. And that's really the key here to find those asymptotes. So vertical asymptotes, again, there's 2 of them. There's 2 of them. There's 2 ways to make us divide by 0 down here. So vertical asymptotes. We've got x equals -4, and we've got x equals +3. Now the horizontal asymptote, very easy. Just look at that number on the end, the k value. Y equals +2. All right. Hey, so for the sketch the graph part, what I would do if I were you first is plot these asymptotes and just do them as dashed lines. Like they're not really part of the function, right? They're just lines that we're going to approach. So first asymptote at x equals -4. It's 1, 2, 3, 4. It's vertical. It's just going to be this line going straight up and down. Straight up and down, just like that. Okay, we have another vertical asymptote at x equals 3. So I'll go over 1, 2, and then 3. This will help you make your sketch of the function later on. So I got the vertical asymptotes plotted. Now I can graph this one, y equals 2. So on the y-axis, I'll just go up to 2. And again, it's horizontal, it's just going to be flat. So I'll draw a line going straight across. Okay. With all that done, let's actually sketch the function. What's the function look like? So it's going to look quite a bit different than what we were doing the other day. So I just put the function into my calculator. So if I go to graph, there it is. Really weird looking function. It's kind of got this curve in the top right, this curve in the top left, almost like a parabola shape down here. So to get credit for your sketch, I'm really not picky at all. There's just one thing that I want to make sure of. When you sketch in these curves, do not cross the asymptotes. One thing that I'll not give you credit for. Like that, perfectly fine. I've got another piece down here. Again, I'm not going to intersect or cross any of those dashed lines, any of the asymptotes. That one just kind of looked like this. Okay, fantastic. And then we had another piece in the top right corner. All right, hey, the function's graphed. Looks pretty good. Just like this, I'm not crossing any of the asymptotes. Maybe I didn't make them as steep as these ones were, but again, I'm not too worried about that part. Okay, we have one more thing to do with this problem, which is find the domain and range. So the domain, of course, talking about the x values, they can range from -infinity up to our first asymptote. So essentially our x values go from something way out here to the left, -infinity, and then they get super close to this line. Never actually get there though. So the first asymptote was at -4. And then the function essentially jumps over that line. It never actually crosses it. So then we can go from -4 up to 3. -4 to +3. And then we can go from 3, the x value can go from 3 up to +infinity. Fantastic. So the range works pretty much the same way. But we're looking at these horizontal asymptotes. These are what's going to break up our function. So the range, the y values, looks like we can go from -infinity up to, not including 2. We can go from -infinity up to 2. Then our function can go from 2 up to +infinity. So for now, really when you write the domain and range, you're just going to be using these asymptotes that you found earlier. And that's really all you're going to be doing on today's assignment. Looking at finding the asymptotes after you fully factor the function, plot those asymptotes, sketch a graph, find the domain and range. All right.